Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, Some Basic Concepts of Chemistry. Most of you guys who are watching this course are class 11 students who have just begun their journey to build up careers as doctors, engineers, scientists. Although this course is going to be awesome, even for students who are in class 12th or at the moment preparing for other competitive exams like NEET and GATE and want to brush up their basics. So, I, Dr. Ritu Johar, welcome you all again. Now, do you know what is required to excel in this course? Well, it is going to be your simple mathematics of class 1 to 5. Yes, I mean addition, subtraction, multiplication, division, and unitary method. And if you are good at your calculations, you are going to do awesome in this course. So let us begin first of all with the salient features of this course. To outperform in any exam, thorough knowledge of NCERT textbook is considered to be of utmost significance, especially in chemistry. Generally, students ignore NCERT textbooks, so we here have tried to incorporate maximum text from the NCERT books. But still, it is my suggestion and request, please do read the NCERT. Whatever portion we cover in the lecture, just go through the NCERT also. This is going to really help you excel. This course will help build your knowledge for attempting more questions in boards as well as the competitive exams because we have put in additional content required for the competitive exams also. The contents are discussed at length in the course, but should you feel any need for further support, please feel free to communicate with us by mailing at h2ochemistry@gmail.com. Now we have tried even to put questions and numericals such that you can tackle any question, be it a simple one or be it a difficult one. So please, still if you feel that there is any further requirement on your side, you need any help from us, please do put in your suggestions, do put in your comments, just mail them to h2ochemistry@gmail.com. Now let us begin with the lecture. In this lecture, we are going to discuss what is matter, what are the properties of matter, and measurements of these properties of matter. Before we begin, let us understand what is chemistry first of all. So chemistry is the branch of science of atoms, molecules, and their transformations. So we in chemistry are going to discuss about atoms, discuss about molecules, how they interact with each other, and what is the result of these interactions. We can also define chemistry as the branch of science that studies the composition, the properties, the interaction of matter. So, what are we going to discuss here? Well, we are going to discuss what is matter. What is matter composed of? What are the substances which form matter? Then what are the properties of these substances, how they react with each other, and what is the result of these interactions, what new substances get formed, and so forth. Now, even before talking ahead, let us really realize why we are studying this subject, chemistry. You are science students, you look around, you see so many things, and you know actually chemistry is all around you. So let us really look around. First of all, what you have a notebook and a pen with you. So the notebook is made up of paper. Where do we get that paper from? Wood pulp. How did we develop the science behind the conversion of wood pulp to paper? That is all chemistry. The pen, the plastic body of it, the refill, the ink in it, everything is going to be chemistry. Your very own body made up of atoms, molecules, matter. Again, chemistry. The cold drink cans, the cold drink bottles you all love to have. Well, Where did we get the knowledge to make them? Chemistry. Look around you, see cars, scooters, petrol, diesel, cooking gas, the utensils, your laptop, everything is chemistry. Because everything is made up of atoms, molecules, matter. So let us first of all study what is matter. Well, matter is anything that has mass and occupies space. So everything around us is matter because everything has some mass and is going to occupy some space. You all have studied in class 7th or 8th, and this is just an revision class for you actually. We are just going to introduce the topic so that you can develop an understanding into the things which we will be learning as a new topic, right? So matter is anything that has mass and occupies space. And what are the three types of matter? The three states of matter: solids, liquids, and gases. So you all know what are solids, liquids, and gases. Well, solids are those which have a definite shape and volume because the forces of attraction between the particles is very strong. They are kept close to each other. They do not have a freedom of movement. Whereas in the liquids, the forces of attraction are not that strong. The particles are close to one another, but still they are free to move. Therefore, they have a definite volume, but not a definite shape. Whereas in the gases, the forces of attraction are not that strong. The particles are far apart from each other. They can move very fast and very easily, and hence they neither have a definite shape nor a definite volume. Now, there are two more states of matter. Well, you have not studied them before, but there are two more states which are plasma and Bose-Einstein condensate. We will be discussing them more in another course, the states of matter in class 11th only. But for the present moment, you can understand that plasma is that state which is at a very high temperature. The particles are highly charged and they have extremely high kinetic energy, right? And in the Bose-Einstein condensate, it is exactly the opposite. It is that state which is at a very low temperature, almost the absolute zero. And at absolute zero, there is no motion of the particle. All motion ceases at absolute zero. So the two states more you have come to know today, they are the plasma, a state at a very high temperature, and Bose-Einstein condensate, a state of matter at a very low, at an extremely low temperature, right? Now also remember here that the states of matter, they are interconvertible. We can convert them from one form to another by just changing the conditions of temperature and pressure. For example, you know ice. You have all done this example. So ice, a solid, when heated, gets converted into liquid water. Further heated, it changes into water vapors. Cool those water vapors, we get the liquid water back again. Cool them further, we get ice back again. So this is just a revision, I hope. Now we can classify matter on one more type of classification. This is on the macroscopic or bulk level. Basically, this is a chemical classification of matter. The classification into solids, liquids, and gases is a physical classification of matter, and this is going to be a chemical classification of matter. Here, matter is classified into mixtures and pure substances, where mixtures can be further classified into homogeneous mixtures and heterogeneous, and pure substances into elements and compounds. We will study them one by one. We have pure substances, and here the composition of the constituents is fixed. Unlike the mixtures where the composition of the constituents was not fixed, they could combine in any ratio. And the constituents, they can't be separated by simple physical methods, right? They require chemical methods to separate the constituents. Common examples of pure substances can be gold, copper, water, glucose, so many more. And then we have the classification of pure substances into elements and compounds. Elements, they consist of one type of particles and they may be atoms or molecules. The elements copper, gold, sodium, potassium, they all consist of one type of atoms. The whole element is going to consist of millions and millions of atoms. Okay, whereas the element hydrogen, oxygen, nitrogen, they consist of molecules of the same type. For example, hydrogen, two atoms combine to form a molecule of hydrogen, and the whole element hydrogen is consisting of many molecules of hydrogen. Similarly, oxygen element, it is going to consist of molecules of oxygen. So why some elements they have atoms of one type and why the others have molecules of one type, that we will be discussing later in the course. But for now, you just remember that the elements, they consist of one type of particles, right? Next we have compounds. So compounds are also pure substances, but here the difference from elements is that there are two or more atoms of different elements which are combining in a fixed ratio to form the molecule of a compound. Okay, so here the atoms are different. For example, water. So we have a water molecule forming the compound water. Here one oxygen atom combining with two atoms of hydrogen, and this is the water molecule. And the whole compound water is going to consist of water molecules. Similarly, we have carbon dioxide molecule. So the carbon dioxide as a compound is going to consist of many molecules of carbon dioxide, where we have one carbon atom and two oxygen atoms. And now they are in a fixed ratio. If you change the ratio, then they may form another compound. For example, if we have carbon combining with one oxygen, this forms a compound called as carbon monoxide. So this would be entirely different from carbon dioxide. So the ratio has to be fixed and there are going to be two or more atoms of different elements combining in a compound. Let us start with mixtures. Mixtures contain two or more substances as their constituents in any random ratio. Well, this word random ratio is very important because in the mixtures, the ratio of the substances is not fixed. For example, you can take forming of a sugar solution. You take a glass of water, take a bowl of sugar, add 1 spoon of sugar to the glass of water. It is a sugar solution. Add 2 more spoons of sugar to water. Again, it is the same sugar solution. The properties of that sugar solution are not going to change, right? If you put the whole bowl of sugar into water, same it is going to remain the sugar solution, no change in the properties. So the mixtures, they have two or more substances as their constituents in any random ratio. The ratio being fixed is not important. We have two types of mixtures. The first are the homogeneous mixtures. Here the constituents, they are completely mixed together. For example, the sugar solution. After mixing, the sugar is evenly spread throughout water. There is a complete mixing of sugar and water. Similarly, air. This is a homogeneous mixture of various gases like oxygen, nitrogen, carbon dioxide, and so on. Then we have heterogeneous mixtures. Here the composition is not uniform throughout. The constituents are not completely mixed together. For example, a mixture of salt and sugar, grains and pulses. Now please remember here that the components of a mixture can be separated from one another using simple physical means. So simple physical means can be used to separate them. For example, magnetic separation, sieving, boiling, evaporation, distillation, etc. The second topic of this lecture is properties of matter and how we measure them. So we will begin with, first of all, the properties of matter. Well, every substance has unique or characteristic properties, and these can be classified into physical properties and chemical properties. Physical properties are those which can be measured or observed without changing the identity or composition of the substance. We do not change the composition of the substance, please remember. For example, seeing the color, odor, uh, noting down the melting point, boiling point of a substance. So in melting point and boiling point, what we are doing is we are just changing the physical state of the substance. We do not change the composition of that chemical substance, right? In everyday life, we are measuring mass, length, volume. That are what? Physical properties. In scientific studies, we measure the force, pressure, then density. So these are all physical properties, and they do not require changing the identity or composition of the substance. Well, in chemical properties, they can be measured or observed only when a chemical change occurs. For example, we want to study about the combustibility of carbon, right? So we want to see how carbon burns. So what we do is we burn carbon in the form of coal, charcoal, and burn it in air. What do we get? We get carbon dioxide as a gas. So here a chemical change has occurred. A new substance, carbon dioxide, has been formed, and hence we have been able to study the chemical properties of carbon. Right? Other examples like acidity, basicity, there are going to be so many chemical properties of each and every element you are going to learn in chemistry. Okay. So now we are going to learn how we measure these properties. So we can measure these properties uh, qualitatively as well as quantitatively. By qualitative measurement, we mean like noting down the color, the odor of a gas, whether a solid is electrically conductive, thermally conducting or not. So these are the qualitative measurements. But in this course, we are not going to be concerned with the qualitative measurements of the properties of matter, but with the quantitative measurements. Quantitative measurement like measuring mass, length, then volume, area, and such things we are going to do in the quantitative measurements. And what do these involve? They involve expressing a measurement in a numerical value along with the units. So there is a number and the unit in which we are measuring that thing. For example, we have a room 6 meter long. So we've measured that the number is 6, that it is around 6, and the unit of measurement was meter. So the room is 6 meter long. A number followed by the unit. Initially, do you know how people used to measure things? Well, they would measure the distance from one place to another in terms of their footsteps. That this place is about just 100 steps away from my place, and the length of this cloth is just about 10 hands of mine. And then the various system of measurement developed, the initial being the English system, which was the foot, pound and second system, and the metric system, the MK system, which you all know, is measuring in meter, the length, the mass in kilogram, and time in second. And this metric system was a convenient system because it was based on the decimal system. But always the scientists all over felt that there was need of a common standard system of measurement. So in 1960, such a system was developed, and this is known as the System International Units, the SI system for short. And this was established by the 11th General Conference on Weights and Measures. And this system has 7 base units for the 7 fundamental scientific quantities. And these are the length being measured in meter, mass, kilogram, time, the SI unit is second, electric current is ampere, thermodynamic temperature is Kelvin, amount of substance measured in moles, and luminous intensity in candela. So many of these you have already been using, like the meter, the kilogram, second. Even in 10th you studied electricity, so you know that ampere is the unit of measuring electric current. Kelvin, you have been converting temperature from degree Celsius to degree Fahrenheit to Kelvin, so you know all these things. Even more you have studied somewhat in 9th and 10th. So you have been using most of them. You will come to know of the others. And do you know why these are called as the fundamental scientific quantities? Because every other physical quantity that can be expressed in terms of these 7 fundamental quantities. For example, volume. You know, what is the volume of a cube? That is length cube, right? A cuboid, LBH. You have been learning these formulas in mathematics. Then density, mass over volume. So these fundamental units can be used to express any physical quantity. Now, the definition of these quantities have been given in the NCERT. Just do have a reading of that also. Plus, in the NCERT, there are given the system prefixes to convert one unit into a smaller or a larger unit. For example, converting meter into a centimeter or meter into a kilometer. So these all prefixes for these have been given in the NCERT. Just have a look. You have already been using them, so I'm just not going to put more time on that. In the next lecture, we will be discussing about how we can we can express these measurements which we are doing, right? So we would meet again for lecture 2 on ways to express measurements, wherein we would learn about scientific notation and significant figures. Well, if you liked my lecture, please do upvote for me. Also, do subscribe to my course so that you get a notification as and when I put up a new lecture for you. You can mail in your suggestions, any difficulties you are having at our email ID, which is h2ochemistry@gmail.com. Bye for now. Enjoy yourself. Have a nice day. Goodbye.